Hello everyone and welcome back. Now this is a short video because here I'm just going through a code snippet, but I'll provide this complete notebook in the resource section so you can follow along. I just don't want to repeat the whole code which we have actually programmed before, right? So what I did here was I imported TensorFlow, then TensorFlow datasets, TensorFlow Hub, and also here sequential API as well as NumPy. And then what we did here is we basically used now the mobile net v2 because I wanted to explore another pre-trained model and use it and just compare what the results are. So I downloaded it here with the URL using this extraction layer. So it's called hub.keras layer. It's basically from TensorFlow Hub. You would simply use or input an URL, which is this one currently, and you define the input shape, which for this mobile net v2 here, this one is 224 by 224 and 3 color channels. And then we specified here exactly the same as we did with the efficient net. We said that the layers we extract here are basically false. The training for those should be false because they are already trained, right? We don't have to go through the hassle and train them again. We don't want this. Instead, what we want is we want to use all those layers and then add simply one additional layer. In this case, I only used one dense layer. I also tried other things like global average pooling and flatten layers and so on, but I ended up with this one dense layer with 3 classes. Remember, again, it's the same as when we specify the efficient net and said we don't want to have the top layer, right? That's basically the same idea behind that. But simply the code is a little bit different. But then we simply add the three neurons at the end. So because we have 3 classes, rock, paper, scissors. Then we printed a summary here, which is this one, and then we compiled it. The same way, we have an optimizer, we have a loss here, and we have the metrics, right? So those 3 things we specify here. And then we load the data, here rock, paper, scissors, exactly the same way as we've done before. We have a training data set, we have a testing data set, then we pre-process the data set here by resizing it. Here we need to specify the dimension. Remember, with the efficient net, we had basically 32 by 32, but here, of course, because the input shape is defined here by 224 by 224, so for image width and the height, we basically also adjusted the size here for the training data set as well as for the test data set, okay? Then we do exactly the same steps. We convert it into NumPy arrays, like here, for the, in this case, all the images as well as the labels. Then here we can print out the shape, and we see that here we go get the shape 224 by 224 by 3. So not 32 by 32 by 3, but in this case, the new shape. Then we converted this to floats, and we divided it by 255, simply because we want to normalize the data, so the network will be easier to train. So, and then finally we ran it here. Here I used 3 epochs. I also tried other epochs, 8 epochs before and so on. But you'll see that the accuracy when you try it on your own is pretty fast, or converging to 100%, right, on the training data, which is great. But as we all know, training data is actually data which the model has seen, which it is trained on, but we want to get the real life experience. So basically we want to expose unseen data to the model and see how it performs, and I did this here as well. And here with the evaluation I went up to an accuracy of 81.99%. okay, so almost quite similar to the efficient net. I just wanted to try one different thing, and I also, of course, as I said before, attach this to the resource section so you can use it and try it on your own as well. Okay, so that's it for the short video. As always, thanks so much for watching, and hopefully see you in the next video. Until then, best guys.